I am joined by industry leaders, decades of leadership in open source space, SUSE, Canonical, Red Hat. All these companies compete in the marketplace, yet they collaborate upstream, and we love those collaborations. Why don't I ask you guys to introduce yourself and the work you're leading in the ecosystem, and then we can get started with a few questions, and we will open up for the audience for any questions you have for our distro friends here. Darren, why don't you get it?
So Darren Davis, Senior Partner Technology Manager at SUSE. I've been with SUSE for 21 years in lots of roles, all the way up to engineering management. Currently, I work for doing the silicon enablement, and RISC-V is that silicon which we want to enable now.
Great. Nice. Hi, everyone. My name is Gordan Markus, and I'm working for a company called Canonical, but you're maybe more familiar with the African word that Ian mentioned, which is Ubuntu. We're the makers of Ubuntu. And similarly to Darren, my role is also working closely with Silicon partners, and I've been working at Canonical for 4 years. But before that, I had vast experience in open source communities, so I'm really happy to be here. And I really love the energy that we're seeing in the RISC-V community. It's really something close to the open source ecosystem in software that we're seeing as well.
Good afternoon. My name's Steve Wanless. I work at Red Hat. The role I have inside of Red Hat is preparing the business case for Red Hat Enterprise Linux to pick up new technologies, and RISC-V is one of those new technologies. The other new technology I'm working on, just as an example, is CXL3 switched fabrics.
Great, thanks, Steve. That's a great segue. What investments have you guys made into RISC-V enablement so far, whether it's engineering, infrastructure, or upstream collaborations? Gordan, why don't you get us started?
Oh yeah, absolutely. I think like one of the most obvious cases is that we are here. We're present already for 4th year in a row, and I think we're like actively sponsoring and joining the community. But of course, like it doesn't stop only there. We're also members of the RISE community together with our partners, where we make sure that we advance the broader open source ecosystem together as a community. And internally, we have dedicated teams working on RISC-V enablement. But I think the biggest amount of effort that's actually happening is not just the dedicated effort that's happening for RISC-V, but it's actually how it's reflected on the whole of Canonical, right? Recently, we moved to RVA 23, and the amount of infrastructure we had to tune and actually also to help us to achieve that, it was really something inspiring. So I think that if you look at just the people here in this room that you will meet with orange t-shirts, they're doing amazing work, right? But I think like the whole Canonical family is actually standing behind the big effort that Canonical is bringing here to the community.
Darren?
Yeah, so for SUSE, obviously it's collaboration with RISC-V International, all you folks. By participating, we can grow, RISC-V to new levels. In terms of investment, we obviously have our engineers, and we are focusing on OpenSUSE Tumbleweed. So OpenSUSE Tumbleweed is our rolling release, and interestingly is the start for all our Linux distros or products that SUSE builds. So a community built around that, and it's built using our OpenSUSE build service, which is a public build service, build.opensuse.org. And interestingly, the OpenSUSE build service builds for many Linux distros, including our companions here. So using that, anybody, you guys who want to build software, you can use the OpenSUSE build service. It's publicly available. And with that, then we grow and build the packages together.
So to echo what Gordan said just a minute ago, Red Hat has become a partner inside of the RISE organization, which we feel is essential for establishing the software environment on top of a RISC-V hardware implementation. And it's still something I think that's still, it's in its evolution. If you look around the different sessions at this conference, you can see that the focus is still very much on hardware. You're probably aware, or maybe not, that Red Hat released a developer's preview of our brand new operating system release, Red Hat Enterprise Linux version 10. We released a developer's preview of that for a RISC-V platform, working with Ian, who was just here a minute ago, with Sci-5. And primarily the work that we did there was all pushed upstream. So we moved, for example, the upstream kernel that was available for a RISC-V implementation from, I think, 6.5 up to 6.12, which is what the Red Hat Enterprise Linux 10 implementation is at. So there's a lot of work going on, but the good news is that in the world of upstream and RISE, it benefits everybody.
Exactly.
Yeah, Jeffro had a great introduction on the lightning round on the RISE project. We have invested in compiler space in GCC and LLVM. There are a few projects there now that AI being the top of mind for all of us. We're looking at multiple projects from RISE standpoint for PyTorch, llama.ccp, and there's more efforts that's going to come in RISE side as well. So my second question is, what upstream project outside the kernel is the critical path for your RISC-V enterprise readiness and that needs more contributions?
Yeah, I mean, of course, we've had distributions now in RISC-V for quite a while, so obviously kernel tool chain, we can always get better performance and chase that. But I think from our perspective, there's a huge ecosystem of software, and Jeffro just mentioned this. We really need focus on all those other areas, the databases that we all use for full solutions. It's those other projects that may get ignored that I think are the highest priority, because in the end, when we start assembling all this stuff together, then we start finding out, hey, this isn't working quite right, or hey, this could be more performant, and we would really like to see the focus, go there. Obviously, there's a huge community already working on Linux together, and we are really, all of us are focused on making that work as best as possible.
Go ahead, Gordan.
Right, and I mean, I completely agree with that. Right now, when we see the work that all of us have been doing together, and together with you folks in the room in advancing the open source software ecosystem on RISC-V, it's amazing work. But we're right now at the foundational levels, and I think we're probably gonna, in RISE, climb up the stack, right? Looking at more infrastructure-grade open source software, for example, like Kubernetes, OpenStack, and similar type of solutions, because this is also something that's very important for us as distribution vendors or open source vendors to be able to provide our full offering, right? Then also to Darren's point, like databases, analytics, and other type of stacks, they're all out there, right? And we see right now there's still a lot of spaces where it needs a bit of more work. Right,
yeah, absolutely. Dependencies are deep
Exactly.
and broad.
Yeah, exactly that.
Deep and broad, so all of you are providing a solid foundation to the ecosystem. Steve?
So I agree with what was said in terms of some of the higher up pieces of the ecosystem. The tool chains, definitely an optimized version of Valgrind, for example. But we still have some missing pieces of essential infrastructure. So let me give you an example of what's missing that we still need to work on. Secure boot. Who's going to become the signing authority for RISC-V in secure boot? And who's actually going to create the shim and all the work that goes into doing that? So while we can talk about databases and those kind of things, there are still some big holes in our infrastructure that we, as an industry, need to address going forward.
Great, thank you. What RISC-V International standards and/or specs are key to Linux distro vendors for you guys? How do you look at that?
Me? Okay.
We can start with Steve. How about that? Yeah.
Okay. Well, so firstly, let's give a shout out to RISC-V International, because a lot of their standards have now become ISO standards. Absolutely. That was one of the things that got announced earlier today. with the Joint Technology Committee of the ISO organization. So I think that's great. So, I mean, you know, standards are always a good thing. Oh, what else are we looking at? So let me ask a couple of rhetorical questions, and I don't want answers. I just want you to think about it. So the last time you installed Linux on a RISC-V system, how did you do that? I bet you did that with an image file that was on some piece of media somewhere, and you booted off of that image file and maybe copied it all over onto a more permanent device. So there's that. You might be thinking to yourself, where's my ISO file? The other thing is, you might have noticed that there aren't too many cloud vendors out there using RISC-V. Now, a big shout out to Scalaway, who is the cloud vendor that I know of, but Scalaway is giving every single one of their customers a piece of physical hardware to run on. It's not a virtualized cloud. So you might be wondering to yourself, where's my hypervisor? So that's how I tie back into what's missing in terms of standards. So I think all three of us sitting here as Linux distribution vendors for RISC-V, we would all like to be able to provide a single bootable binary across a wide range of hardware. Those components, those standards in the RISC-V environment don't exist yet. And I was really pleased to see Andrea this morning talking about how ACPI 6.0 now supported RISC-V. That's going to be a huge step forward for us in terms of just establishing a single binary that can boot across multiple platforms. But we still don't have a full RISC-V profile that is for a data center server. Now, I know that one is it's going into for a ratification relatively soon. I think if it gets ratified in next year, probably next year, we're not going to see hardware that supports that until maybe the end of 27. So hardware, it's an issue for us.
Yeah, it is. It really is.
So uniformity is absolutely important here, and each of you add your value based on your customer needs. Gordan, any inputs from your side?
Yep, I agree with Steve as well. Like the profiles, of course, and big congratulations, like what happened last year with RV23. What Steve said as well, right? It takes some time from ratification to actually seeing products on the market, right? The server platform specification, I think that one is also key, coming back to the point of how the boot chain looks like, how things can be uniformly done with a single image. But then there's also like a lot of the work that's happening in some other, let's say, specification groups, for example, like the matrix extensions or security. We're very much interested in confidential computing. We want to make sure that basically there's parity with all the other ISAs, and especially like we're trying to make the ISA future-proof. And I think that it's really great that RISC-V is also looking in that direction, but we'd highly encourage the folks, you know, to also accelerate the pace here, because we need to understand like how are we going to solve and tackle that problem. Because once we start building things, we want to really stabilize and want to make sure that we can provide our customers with that predictability, stability, and security support, right? So I think that I think that we're also invited in these forums. And if you think that we should be in some of those forums where these topics are discussed, make sure to reach out once again to us.
Darren?
Yeah, and for me, obviously it started with profiles, so RVA 23 was very huge for all of us, and now it gives us a target to focus on. Definitely the server platform specification, that's kind of a next step. But then if I were, you know, we mentioned those, but to me, I think things like debug, trace, you know, we're now going to go into a cycle of where we're going to try to become more performant. We're going to want to make sure everything works very well. So debugging, trace, anything to help us with performance and analysis, that's the next step for kind of raising the bar on the RISC-V platform to be competitive with the other architectures.
Yeah, it's that iterative cycle of let's
always,
port
always.
it, does it work well? Now let's optimize, and then that cycle needs to continue. So here's my last question, and I will open up to the audience here. Looking ahead, where do you see RISC-V fitting into enterprise compute, cloud, and data center environments, especially as AI workloads continue to grow here? Steve, yeah?
All righty. Well, so I think that we're going to see RISC-V really enter the market as a platform for AI workloads. And I say that because when you look at the components of an AI workload, there's very, very little legacy inside of that software stack. So you have PyTorch up and running, you may or may not choose to accelerate it. Once you're at that point, you then have a choice of a whole bunch of different LLMs or other components that you can run on that platform. I think that AI is despite whether you think it's a bubble or not, I think AI is very much an opportunity for RISC-V to use that as a route to market with very, very few bars to cross. So I think AI is going to be a great thing for RISC-V.
Darren?
Yeah, from my perspective, there's activity on all scales in RISC-V. But I think some of the immediate things we will see is definitely an edge AI, as Andrea pointed out, is going to be a huge explosive, kind of the immediate takeoff area. Industrial IoT, of course, automotive is RISC-V is taken off there. But from SUSE's perspective, yeah, edge and industrial, I think that's going to be kind of one of our big entry points for providing enterprise Linux.
Great.
Yep, I think that from our point of view, like if we look at the general purpose compute, I think that what is really essential is that there will be cloud adoption of RISC-V general purpose compute solutions, because that's going to make sure that the software ecosystem on all fronts will catch up. In the meantime, there's probably going to be deployments inside of the data center that might be characterized as offload components. I think that's what my kind of crystal ball would say. For example, like a data processing unit or an offload unit for cryptography. That's where RISC-V could be very well used almost immediately, because to Steve's point is like that there's limited amount of legacy software there. So that's quite a novel concept, right, in terms of heterogeneous compute. So you're already kind of aware that you're running on a different device, you're offloading it somewhere else, the networking, the cryptography, and so on. But once again, like what we're really seeing right now through the partnership and the work we're doing with a lot of our partners is that the general purpose compute RISC-V hosts, I'm really looking forward to those, to be honest, because I know that's going to be like a huge step forward for the whole ecosystem.
We do envision RISC-V becoming the first-class citizen for AI development and deployment efforts. And the investment needs to be wide, whether that's projects itself like PyTorch or llama.ccp, or dependent directly or indirectly dependent projects like Python packaging. So we, from RISE standpoint, we're investing in across the stack there as well. So why don't we open up for the audience? These are your Linux distros sitting in front of you. So if you have any questions, we already have one hand up here.
It's hard to see it.
Well, absolutely, it's coming to you, so people in the back can hear it as well.
So I'm a silicon guy. I am interested in flushing out all the issues and bugs on bare metal so that software will run. Relative to x86 ARM, RISC-V creates a situation where instead of having one core that 1,000 people are using and feeding back issues on, we have 100 cores that 10 people are using, and they're kind of similar, but not really. My burning question for you is, at the bottom of your software stack, what are you seeing people screw up? Where's the friction, right? What is not working in hardware implementations?
If we had some hardware, we could probably answer that question. I honestly don't know where to go with that question, because if you take 10 cores running at 10 gigahertz, and then you take 100 cores running at 1 gigahertz, what you've got is more, not faster. And then so the real question becomes, how does low-level software exploit the parallelism of multiple threads of execution through multiple cores on the same die, probably pushing up your cache management load quite considerably? We don't have tools for managing that kind of thing. What we do have, I think, as a group of Linux distribution, is the ability to create multi-process environments where multi-processes can be mapped onto or scheduled onto multi-cores. But I don't think that as an industry we're doing anything to address what you're talking about. So what I think your question is probably much more aimed at the high-performance compute group of people who do a lot of work with multi-threading and parallelism.
Yeah, so a comment I would make is, so certainly there is hardware. There's a large number of these, and I would say dev kits. It's not, mass-produced, everybody's all of a sudden adopting hardware. So we have all these various different dev kits, and obviously you guys are trying to bring it to market quickly, and the fact that you're distributing with your own kernel, no upstream work, and we've mentioned, you gotta play in the community. It is key for us to enable later for you to participate in that community. And so we get off, all these little dev kits, and we have little nuances, and it isn't just necessarily the RISC-V cores, it's all the other surrounding silicon where it's like, okay, yeah, we can, I'll have one of my engineers, and they will dig into it, and they can get something working, and then they say, but Darren, this isn't gonna be something you would hand to a customer because we had to do all these things to make it work. So we need, and the ACPI spec is huge for us because we need it to be more streamlined where our goal is we're gonna build one kernel, we're gonna try to support all of your hardware collectively together, right? And we've gotta be able to build that one and run your hardware and your hardware and your hardware, and it all runs smoothly. And so the little variations, the variations in the surrounding silicon, trying to make other pieces of the board work. I think we just recently got boards where we got graphics working, or something like that because of the differences. That to me is the pain points where we got to move beyond that so that we can en masse take over the world.
Can I just add that part of your responsibility as a hardware vendor is to work with the software community to get your silicon support software not just upstream, but accepted upstream. You don't speak the language.
And the relationship, you should have relationships with all three of us. We're all here. We all want to achieve the same goal. And with that, we will help, many years of experience in the Linux community with the companies, and we're here to do that.
Well, we understand your snide response, but we've all got many years of working with hardware vendors under our belts, and probably inside of our lockers we've got the Captain Crunch decoder ring that tells us, how to talk to hardware vendors.
Great, thanks, Steve. I think I see a hand out right up that way.
Thank you. Hi, thank you so much for the opportunity. RISC-V hardware has come a long way since in the last 5 years. The amount of progress in both the hardware and software front is absolutely immense. And I absolutely do believe the claims that RISC-V IP per square millimeter is more powerful and efficient than ARM. But however, the real world implementations of such, I would say they're kind of around Core 2 Duo levels of performance right now, and nowhere near the high performance stuff that a lot of us take for granted today. So I'm wondering what you think is needed in the industry for RISC-V to catch up to its super high performance x86 and ARM counterparts? And if things are to go as projected, how long do you think it'll take for RISC-V to catch up in that regard, and what would be needed?
Why would you be asking software people that question?
This is your opportunity to provide your message to the vendors now.
It was just something that I needed to ask, my bad.
Okay.
Gordan, any message to the vendors on?
Right, regarding that? I think like in generally we cannot comment on performance or anything like that. We're mostly here to make sure that our software runs on the current solutions that exist out there and prepare our software for the next solutions that are coming, right? So that's why, like, for example, we're making sure that RVA23 is going to be a supported profile in our next Ubuntu release. But we cannot know or say when this is going to happen, right? It's our job just to be prepared for what's coming. And we need to have faith. And I really have faith that this is going to come. And I think when I look at all the amazing people in this room, it gives me faith that we're on the right track, right? And that's...
I think the RISC-V hardware environment is going to become a very Darwinian ecosystem.
Those are the marching orders for the hardware vendors. I think we have one question up here.
Thank you. Yeah, I think a simple question. So some of us are working on a certification program inside RVI. I was wondering from your point of view, the importance you see of a certification program in terms of, compatibility of different processes.
That's absolutely essential.
Essential.
Yeah, absolutely essential. That's like table stakes. I think that's table stakes.
One piece of advice, don't push that certification program off to the vendors. That's like putting the fox in charge of the chicken coop.
You don't want the wolves watching the sheep.
Exactly. But secondary, we all of us run certification programs of, production hardware where we guarantee the OS running on that hardware, and we build on that very thing. So, yeah.
So there needs to be
It's
some
essential.
checks and balance. Yep,
Yeah,
absolutely.
it's essential.
And just maybe my understanding is like that also the certification will solve the problem of ISA level certification, profile level, right? As well as the server platform level, right?
Yeah,
So once again, coming back to what's important from the spec point of view, if the certification lab solves all that, then we have very high confidence that when you're fully certified, that our software will be able to run and that it's going to run as expected.
Thank you. Any more questions? Or we should probably let the people go. We are sitting between happy hour and the
Free
people's
as
first
in
beer.
beer.
People's first beer.
The free beer.
Free
Yes,
as in beer.
absolutely. So how about I'll give you guys some parting question. As a leader shaping the enterprise Linux across global markets, what is the one message you want this audience to walk away with about the role and potential of RISC-V? Darren, do you want to?
Well, they coined it, in a previous RISC-V International, summit, which is, it is inevitable, and I think we all see that it is inevitable. So participate for us in the software community, participate in the open source projects. That's the best thing you can do to help us help you, basically.
Jerry Maguire line? Go ahead,
Yeah,
Gordan.
it's very humbling to be here. I would say you're all really amazing people, and the partners we work with, right?
Yeah.
They're really amazing, and that, like I said, that gives me faith that RISC-V is on the right track, and that's why also Canonical and our leadership truly believes in that, and that's why our investment is quite large in RISC-V, even though we're a relatively small company. And I want to thank you all for all the great work you have been doing over the past 15 plus years, right?
And so I think what I'd add to that is if we do it right, it's not a question of if, it's a question of when. And so what I would say is, do you hear that sound, Mr. Anderson? That is the sound of inevitability.
Well, thank you all. This is a great point to stop. Thank you all for our panelists showing what real collaboration in open source looks like, even among the competitors. As we move forward, let's keep the momentum upstream. That's where it matters the most. And let's make RISC-V thrive as a first-class architecture.
Thank you all.
Yeah, thank you all.